So I want to give you some guidance here for the Massive Conservation Lab. So the instructions for this are fairly clear. You go into the lab, you get all the data that you need to get, and then you can do the math on it to figure out what the answers to the questions are. So what I've got here is, excuse me, what amounts to fake lab results. These are not the results you would get if you went in and did the actual lab, but it'll be good enough so that you can see exactly what you need to do to get the answers that you need to get. Alright, so the first thing it's asking for is, let's say this is all the data we have. Calculate the combined mass of the two reactants, the 5% vinegar and the sodium hydroxide. Now I think what they've done here is they've made the assumption that both of the Erlenmeyer flasks that contain the reactants, let's draw a picture of them over here. Sorry about that. Okay, so this is not a really great picture of an Erlenmeyer flask, but it's good enough. And what they're assuming, I think, is that both of these Erlenmeyer flasks have the same mass. Now, one of them has about 50 mils of 5% vinegar in it. And the other one has sodium hydroxide, or NaOH, in it. Now in the lab, I think what you do is you end up adding one of these to the other. In this case, it doesn't matter which, because both of these flasks weigh the same, but in a real lab that wouldn't be true. And they make that point in the actual lab, but here they don't distinguish between the two Erlenmeyer flasks in the results. So I guess the assumption is they both weigh the same thing. So what we have here is a situation where we have the mass of the flask and the 5% vinegar is 160.000 grams. Now, in the lab, if it says 0.000 grams, that's what you've got to include in your results. The number 160 and 160.000 are two very different numbers due to the number of significant figures. Now, we talked about that in the first lab that we did, lab skills one. But if you've got 160.000 and 160, these are actually different numbers. I know they look the same, but they're actually different. This one has 6 significant figures, and this one actually only has 2 significant figures. And if this affects the number's accuracy. I'm not going to go into exactly why that is, but just take my word for it that if you've got this many places recorded on the balance, that's what you're going to have to put in your results. You just can't put 160 just because you want to round it. So we've got 2 of these, and the other one is 155.00 grams. Now we're making the assumption that both of these Erlenmeyer flasks weigh the same thing, and they weigh 100.000 grams. And that's the empty flask. So I'm hoping that you can see that the way we would get the combined mass of the two reactants is that we would take the vinegar in the flask. That's the total mass of the flask and the vinegar. I'll say that's total. And that's total for that one as well. And what we would do is we would take the mass of the mass of the vinegar and the flask, subtract out the mass of the flask, and that would give us 60.000 grams, and that would be the mass of the vinegar. Now for the other one, we're going to do the same thing. We're going to take 155.00 grams, minus out the mass of the empty flask, and that will give us 55.000 grams, That's the mass of the NaOH. Now what it's asking for is the combined mass of the two reactants, the 5% vinegar and the sodium hydroxide. So the way we would do that is we'd take the 60.00, add it to the 55.00, and that will give us the combined mass of the two. In this case, it would be 115.00 grams. 0.000 grams. Okay, calculate the combined mass of the contents of the flask after the reaction. Now we do have here, I'm going to clear all that on the screen here. So we add one to the other. In the Erlenmeyer flask, and we're going to have in here now vinegar and NaOH are going to both be in here. Now it turns out the mass of this total thing ends up being 215.000 grams. So if you wanted the mass of the flask after mixing the NaOH and the 5% vinegar, what you would do is you subtract out the mass of the flask from this mixture, and we would get 115.000 grams, and that would be the mass of the mass of the NaOH in the vinegar without the flask. So what we would get from that, if you'll remember, the mass of the vinegar by itself was 60.000. The mass of the NaOH by itself ended up being 55.00. We combine those together, and that comes out to be 115.000 grams. And you can see that these two numbers look pretty similar. And that's what we expect, because that's the whole point of conservation of mass. If you have two things separate and you add them together, you kind of expect the mass to be conserved even after the reaction has occurred. We know a reaction occurred here because the temperature went up. It was 21.5 and then became 32.5 after mixing. Again, this data here is not the data you're going to get in the lab, so you'll have to actually get your own data, but you can do similar calculations to get these results. So the next thing that we're doing is studying the conservation of mass in a gas formation reaction. And you can see that we again have data here. We've got 100 grams, 100.000 grams for the Erlenmeyer flask, and then 121.000 grams after we add water, and then what it would be after we add Alka-Seltzer right after mixing, then after it reacts, and then after gas is released. And you can see what happens to the pressure. The pressure gets released and the pressure goes down. Alright, so let's look at what we're being asked to do here. It says calculate the combined mass of the reactants, the water, and the Alka-Seltzer before the reaction. Alright, so let's take a look at the mass required here. Let me clear this out. we will start this again. So we have again an Erlenmeyer flask. In this flask we've got water, and that's 20 mils. Now we know how much the water weighs, at least you should be able to tell me that, because you've got 100 grams for the flask, and the mass of the flask plus the water is 121.000 grams. The mass of the water then would be, well, I'll do the math on it, but it's 121.000 grams minus the mass of the empty flask, which is 100.000 grams. So that's going to be 21.00 grams for the water. The mass of the flask and the water in the Alka-Seltzer right after mixing is 123.000 grams. So we've got water, and we're going to throw in Alka-Seltzer as well. By the way, you weren't asked for the mass of the water, but I thought I'd tell you how you can get it anyway. And I think you're told in the lab to add 2.000 grams of Alka-Seltzer anyway, but you can see that if you did that, you could add the 2.00 grams to the 21.000 grams of the water, and that would tell you the mass as well. But let's say we do have the mass here for the total, which is 123.000 grams. We subtract out the mass of the flask, the empty flask, and we're going to get 23.000 grams, and that is the water plus the Alka-Seltzer. It says calculate the mass of the contents of the flask after reaction. You can see that we would do something pretty similar with that. We've got, it says after the reaction it's going to be the same mass, it'll be 123.000 grams, and we do the same thing. We subtract out the flask, and you'll notice again we're going to get the same result, which is again a question of what we expect to see. Now remember, at this point the flask has not had the gas released, so the gas is still in the flask along with everything else. So after reaction, the flask might look like this. The Alka-Seltzer will look like it's completely dissolved, but the contents will still be 23.000 grams after reaction. You also have some gas in here as well. That weighs something, and that's also part of the mass of the flask and the reactants as well. Now, after the gas is released, you'll notice that it goes down by a certain amount, and I think it should be clear to you it's going down in this case by 0.500 grams. So what happened? Well, the gas got released, so the mass of the whole thing went down, and we can figure out the mass of the gas. And as I said, we can do that by taking the flask after the reaction and subtracting the stuff from here, 122, which would be 22.500 grams after we take out the mass of the flask, and that gives us the mass of the gas. Alright, so that's pretty much all of the math you'd have to do for this conservation of mass lab.